Okay, we are going to start with our final panel of the day. And at the outset, I'd like to thank those of you that are still here, as is true with live conferences, which some of you may still remember. Often by the end of the day, the seats are sparse. But always appreciate that there are motivated people that are still in the mix. And I think this will be a great panel. So I'd like to introduce Sarah Cooley, who is Director of Climate Science for Ocean Conservancy, who will be both a panelist and the moderator for our last panel. So to you, Sarah.
Thank you. Thank you, Will. And thank you to everyone at AU for bringing this conference into reality. It's been fascinating so far. Yes, I'm Sarah Cooley. I'm the Director of Climate Science at Ocean Conservancy, which is an NGO based here in Washington, D.C. I will be joined by two other panelists today, and I'll introduce them in a second. I think from the span of the presentations and discussion that we've heard in this meeting so far is there's a whole lot of urgency to act on climate. It's loud and clear. What we wanted to do was to really look at carbon capture and sequestration and learn the lessons that we could from there and see how much it was applicable to ocean CDR, because carbon capture use and sequestration is much more advanced than most ocean CDR methods. So we wanted to take a look at the existing legal standards for CCUS and see what kind of parallels existed, especially where it comes to the legal framework, concerns about evaluating effectiveness and environmental impact. And so I'll be joined today by Romany Webb, who is affiliated with Columbia Law School and the Sabin Center for Climate Law. She will present first. And then next, Tracy Hester from the University of Houston Law Center will present. Each of us will have a short presentation, and then I'll quickly ask for clarifying questions right after anybody's talk, but then we're going to save a lot of time for a Q&A at the end, where folks from the audience are invited to raise their hand using the raise hand feature, and then add to the conversation. So let's begin with Romany. Romany, take it away.
Thanks, Sarah. And hi, everyone. As Sarah said, I'm Romany Webb. I'm a research scholar at Columbia Law School and a senior fellow at the Sabin Center for Climate Change Law. Some of you might have heard me yesterday plugging some work that we're doing on international and domestic legal issues associated with 4 different ocean CDR techniques. We also do a lot of work on carbon capture, utilization, and storage. So I'm really pleased to be included in this panel and grateful to Sarah and Tracy for including me. I wanted to kick things off by providing a bit of background about the sort of policy and legal framework for carbon capture, utilization, and storage in the US, primarily at the federal level. The Biden administration has recently been really quite vocal in its support for CCUS. In an interview in June, the Secretary of Energy, Jennifer Granholm, said, and I quote, "I know carbon capture is not the favorite of some in the clean energy world, but we need to look at it. The Intergovernmental Panel on Climate Change has said that we will not meet 100% net zero carbon emissions by 2050 without carbon capture and sequestration." Later in the same interview, she said, "Carbon capture technology, building it, maintaining it, and storing emissions in the ground, building the pipelines for it, all of that creates big job potential, and especially in parts of the country that have historically relied on fossil fuel industry jobs." A few weeks after she gave that interview, the White House Council on Environmental Quality published a report which said that the Biden administration is, and again I'm quoting, "committed to accelerating the responsible development and deployment of carbon capture, utilization, and storage to make it a widely available, increasingly cost-effective, and rapidly scalable climate solution across all industrial sectors." And it's not just the Biden administration that has been supportive of CCUS. We've also seen quite a lot of support from members of Congress. So I'm just going to share my screen so that I can put some graphs up here. So you can see here funding that's been appropriated by Congress in recent years for CCUS R&D between fiscal year 2016 and fiscal year 2019. We've been seeing around $200 million per year. That figure actually increased in 2021. We saw funding of about $230 million appropriated for CCUS R&D. In addition to this sort of direct government funding, we've also seen other actions to support and incentivize CCUS, the most notable being the 45Q tax credit program, which I'm sure many of you are familiar with. Was first adopted in 2009, significantly expanded in 2018, provides for certain projects involving the capture of carbon dioxide at industrial facilities or through direct air capture to obtain a tax credit. The amount of the credit varies depending on what's done with the carbon dioxide. In order to be eligible for the credit, a project must either utilize the carbon dioxide for enhanced oil recovery or for other approved purposes, or must geologically sequester it in underground formations. And the amount, as I said, the amount of the credit is tied to which of those happens. In the case of sequestration, I think a little known fact that the sequestration can actually occur either onshore or offshore in subseabed geologic formations within the US territorial sea or the EEZ. So far, we haven't seen we haven't seen any development in offshore, but there is certainly growing interest in the offshore, as I'll talk about in a moment, and Tracy will also talk about. This graphic shows CCUS projects both developed and under development in the US, based again on what's done with the carbon dioxide. So you can see here there's some enhanced oil recovery projects, some dedicated storage projects spread throughout the country, mostly involving storage in saline aquifers. But as I said, there is growing interest in the possibility of storing carbon dioxide offshore, particularly in subseabed geologic formations that are comprised of basalt, which is, as I'm sure many of you will know better than I, and a type of igneous rock which has been shown to react with carbon dioxide to form solid carbonate minerals. So effectively, the carbon dioxide becomes a sort of solid part of the rock. And that's what these graphics are showing. The sort of white part is the solid carbonate within the darker basalt rock. Initial sort of studies and trials have shown that this mineralization process, this carbonation process, can actually happen quite rapidly. There's a project in Iceland called CarbFix, which involves injecting carbon dioxide into an onshore basalt formation. And initial results from that project showed that 95% of the injected carbon dioxide mineralized within 2 years. And because you have this rapid mineralization, this rapid conversion of the carbon dioxide into a solid, that significantly reduces the potential for subsurface migration of the carbon dioxide, and also for leakage or re-release of the carbon dioxide back to the atmosphere. There are a number of basalt formations onshore, but there's also some really large and significant basalt formations offshore. And my organization, the Sabin Center for Climate Change Law, is involved in a few projects looking at the feasibility of sequestering carbon dioxide in subseabed basalt rock formations off both the east and west coasts of the United States. This one over here, known as the Cascadia Basin, it's a formation that straddles the US-Canadian border. You can see it here, it's this yellow shaded area. Straddles the US-Canadian border off the west coast, so off the coast of Washington State and British Columbia in Canada. It's a really significant reservoir. It has significant capacity, you can see here, capacity exceeding 750 gigatons of carbon dioxide, which is equivalent to about 20 years of global CO2 emissions. So we've been involved, as I said, in a few projects that are looking at the feasibility of using these offshore basalt formations as storage sites. One of those projects is known as the Solid Carbon Project. It's being led by researchers at Ocean Networks Canada at the University of Victoria in British Columbia, Canada, and includes an international research team, including us at the Sabin Centre. The idea behind the project is to develop an integrated offshore negative emissions system. The system would use direct air capture technology to remove carbon dioxide directly from the ambient air in order to reduce sort of transportation costs and other logistical challenges. That direct air capture facility would be located offshore, either sort of in shallow waters relatively near to the coast or further offshore, as you can see here. In both cases, the system would be powered most likely by offshore wind, though tidal energy could also be an option. The carbon dioxide that's captured through the direct air capture facility would then be transported either via pipeline or via ship to an injection site, and the carbon dioxide would be injected into the subsea bed into the basalt rock formation in the Cascadia Basin. We're also exploring this kind of novel idea that would have the direct air capture facility mounted on a ship and would use sort of the movement of the ship to power the facility. You could, of course, also do something very similar, but capture the carbon dioxide onshore, either using direct air capture or at industrial facilities. So our second set of projects that we're involved in is looking at the potential for capture onshore at power plants or other industrial facilities. This is just one example scenario that we've been exploring, looking at the possibility of capturing carbon dioxide at a power plant in Washington state, transporting that carbon dioxide to the coast, and then taking it offshore and injecting it into the Cascadia Basin. As you might expect, the sort of transportation costs and logistics associated with this create some additional challenges than having an entirely integrated offshore system. But that integrated offshore system has its own challenges in terms of various engineering challenges, including sort of materials wear and tear in an offshore environment. So obviously, either of these approaches could raise a host of legal issues and challenges. I want to just spend a few minutes talking specifically about the legal issues associated with the storage component of these projects. So the capture and transportation of the carbon dioxide could have their own legal challenges. There are significant legal issues and uncertainties around things like the permitting of carbon dioxide pipelines and other aspects of capture and transportation. But just for this purpose, I'm going to focus on the storage component. The sort of legal and regulatory framework for offshore storage depends on where that offshore storage occurs. I think we've heard before in this conference about this distinction between US state and federal waters. Generally speaking, the US states have primary authority over areas within 3 nautical miles of their shores. One exception being in the Gulf of Mexico, where Florida on its west coast and Texas have primary authority over areas extending out to 9 nautical miles from shore. The federal government also has some overlapping authority within those state waters, and it has full authority over so-called federal waters, which extend beyond state waters, typically out to 200 nautical miles from the coast. If we're operating within state waters, there is a, whoops, oh, I've lost the slide. That's okay. If we're operating within state waters, there is a reasonably well-established sort of legal and regulatory framework for that operation. I think Tracy's going to talk a bit about this too, but just like onshore carbon storage or sequestration operations, offshore operations within state waters are covered by the Environmental Protection Agency's Underground Injection Control Program, which, as many of you will know, was established under the Safe Drinking Water Act. That act, of course, intended to protect underground sources of drinking water. And so the UIC program, the Underground Injection Control Program, is aimed at sort of restricting, preventing underground injection that could endanger those drinking water sources. As part of the program, EPA has designated 6 classes of underground injection wells, which deal with sort of different, are used for the injection of different types of materials. And a few years ago, EPA designated a new well class 6, which is specifically for the injection of carbon dioxide into underground subsurface rock formations for the purposes of sequestration. EPA regulations provide for the permitting of class 6 wells, also include requirements around the design, siting, construction, testing, monitoring, etc. of wells. Interestingly, those sort of requirements were really designed with a particular type of formation in mind. It was sort of, at that time, the focus was on using things like depleted oil and gas reservoirs, saline aquifers, etc., for carbon storage. And there is, I think, a question as to whether they're appropriate for injection into this sort of basalt formation, where you do have this rapid mineralization or carbonation of the carbon dioxide. But having said that, there is an established sort of regime for allowing carbon storage in state waters. It's still largely untested. So far, I think the EPA has only permitted 2 class 6 wells, both onshore. So there's some uncertainties and questions, but there is at least a framework. That's not yet the case in federal waters, where there's no sort of dedicated legal framework for carbon storage in federal waters. There are, though, some federal statutes that could apply to storage in those areas. The 2 primary ones being the Outer Continental Shelf Lands Act and the Marine Protection Research and Sanctuaries Act. The OCSLA deals with leasing of the seabed underlying federal waters, authorizes the Department of the Interior's Bureau of Ocean Energy Management to issue leases allowing the use of the seabed. The act was primarily designed to facilitate energy development, offshore energy development. So BOEM can, for example, issue leases for oil and gas drilling, renewable energy development, etc. Because of the way the statute's currently worded, BOEM can only issue leases for carbon storage projects that involve the storage of carbon dioxide captured at coal-fired power plants. Any other type of carbon dioxide captured at natural gas-fired power plants, at other industrial facilities, or through direct air capture, you can't get a lease. In addition to a lease from BOEM, these sort of carbon storage projects will likely also require permits from EPA under the Marine Protection Research and Sanctuaries Act. That's actually the act that implements the US's obligations under the London Convention. So it deals with ocean dumping. But the definition of dumping in the act is quite broad, and EPA has concluded that that definition could include the subsea bed injection of carbon dioxide, at least in some circumstances. Under the act, you need a permit to dump, and but importantly, the EPA can't issue permits for the dumping of industrial waste generated from manufacturing or processing plants. And there is, I think, a good argument that carbon dioxide captured at power plants or other industrial facilities is an industrial waste. And so a permit couldn't be issued for the subsea bed injection of that. Permits likely could be issued for the injection of carbon dioxide obtained through direct air capture. But as I said before, you can't get a BOEM lease for that. So as it currently stands, the legal framework is really quite prohibitive of carbon storage in the subsea bed underlying federal waters. That, though, looks like it might change because in the bipartisan infrastructure bill that passed the House, I guess, in July and the Senate in August, it included amendments to both of those acts, the Outer Continental Shelf Lands Act and the Marine Protection Act, that would facilitate offshore carbon storage. So basically, the amendments would put BOEM in charge here. BOEM would be specifically authorized to lease land on the Outer Continental Shelf for carbon storage, and EPA permits would no longer be required for those storage projects. So, it still remains to be seen how that moves forward with the reconciliation process that's underway, but certainly a very positive development. I think I've used up all of my time, so I'm going to stop there and I guess hand back to Sarah or hand over to Tracy.
Thank you, Romany. That was great. I just wanted to quickly open up to the audience. Are there any clarifying questions that you need answered so that you can digest the content of Romany's talk? I don't believe I'm seeing any hands. Okay, with that, thank you, Romany. Let's turn to Tracy. Tracy, take it away when you're ready.
Okay. Good afternoon, everybody. It's always a pleasure to join these types of events and to work with Will. Will, first of all, say it's always a challenge to go after Romany on a presentation. She did her usual excellent job. And I also will apologize because I think I may be the only person in this entire workshop who's actually wearing a tie. That is not masochistic. It's just I did teach classes a little bit earlier and it's still a little bit old school. So please, this is not a sign of over deferential respect for everybody online. So with that, I just wanted to transition. Essentially, my job is to take some of the issues that Romany has talked about and focus on how they might actually play out in a region where it could actually have some significant impacts. Now, in that regard, I wanted to make very clear some of my goals. One is which is to not get distracted. I very much want to focus on ocean CDR and look at issues related to ocean CDR as they might be highlighted by offshore carbon capture storage. So to the extent that we're going to be talking about CCUS to some extent, the ultimate goal is to turn back at the end of the day and talk about ocean CDR. So I will circle back at the end of my presentation and try and draw a few basic thoughts together for discussion. Also, the reason I'm doing this, the reason we are all doing this is because I think twofold. One, ocean CDR is likely going to have strong similarity and overlap with approaches we're going to be seeing with offshore carbon capture storage, both in terms of location, infrastructure, operations. Also, I think it's most likely that some forms of ocean CDR will require offshore CCS or at least benefit from them. So there's a definite synergy here. I will also, though, add an important final point before I turn on my PowerPoint and start sharing my screen with you, which is I want to be upfront that I realize and recognize and very much want to respect that people have a strongly differing view on CCUS. There's concerns, obviously, that it has some opportunities for moral risk and for perpetuation of infrastructure that is of long-term harm to the environment. And also, frankly, that there's an opportunity cost, that the money that we could spend retrofitting the older infrastructure might be better dedicated to building up a new carbon-free infrastructure. But as Romany pointed out, most forecasts, most modeling scenarios anticipate that we are going to need some form of CCUS, if anything, just as part of a transitional period and trying to get emissions down more quickly than we'd otherwise see with pure mitigation approaches alone. So with that in mind, I'll go ahead and share my screen with everybody. And hopefully this will work. And if this is working, everyone should be seeing my PowerPoint.
And we are.
Excellent. Thank you very much. So first of all, let me begin by just highlighting that as someone who's been down here in Texas for a while, there's been a lot of talk about CCUS for a long time. And a lot of it has been, like fusion. It's always been over the horizon. It's the old joke that it's always 50 years away. That has changed. There's a lot of very focused discussion about CCUS as an important and vital transition technology for the energy sector, not only in Texas and Houston, but also generally the United States and globally. The energy sector is well aware of the need for some form of carbon pivot, and CCUS is viewed as an important, if not indispensable, portion of that. As a result, probably the highlight that's caught most people's attention down here that might shed some light on some of our ocean CDR discussion is ExxonMobil has proposed a $100 billion public-private multi-user carbon capture system project that would be installed at the Houston Ship Channel, which is, of course, is one of the larger hubs in the United States for petroleum refining, chemical manufacturing, and other types of industrial activity. This project would essentially capture, pipe, collect, transport all large carbon emitters, like that, about 75 sources that have already been identified, and transport them by pipeline for disposal offshore in the Gulf of Mexico. This is fairly large scale, 50 million tons by 2030 and 100 million tons by 2040 annually. So these are massive scale projects that are explicitly and expressly designed to incorporate offshore carbon capture storage. And when this is not also shallow, they're talking about injecting the CO2 to be 6,000 feet below the seabed. It's not just ExxonMobil. They have now gotten 11 major corporations recently came out in support of this proposal and advocating for it legislatively. So that's an important marker. And they're not small companies. Chevron, Lyondell, Shell, Marathon, Petroleum, Valero. It's the majors are consolidating support, which is a big change than what's happened previously. So with that in mind, this carbon transition, how does offshore CCS fit in? And focusing in particular on the Gulf of Mexico. And I think one thing I just want to highlight, and I'm going to show several maps quickly here, is the distribution of sources and distribution of storage capacity. This map shows United States geologic storage areas, and it parallels probably many you've seen already at this workshop, including some that Romany just showed you. I wanted to highlight the Gulf of Mexico assets. You'll notice that it has a distribution of CO2 sources over 1,000 tons a year clustered along the coastline. You'll also notice that there are some small red swaths along the coast, but the bulk of those red swaths are along the west of Texas and the Panhandle. Those are depleted oil and gas reserves. That is not a reflection that there is not similar capacity in offshore the Gulf of Mexico. The databases have not yet assessed whether or not depleted formations offshore could also be repurposed for offshore CCS. So that is an important issue, which I'll come back to a bit later. But the last thing is notice the yellow extending far off the shore from Texas, Louisiana, and a little bit to Mississippi, Alabama. Those are saline reservoirs. And those are separate from depleted oil and gas formations, which are typically the subject of some of these discussions, or the basaltic formations that Roman was talking about. Saline reservoirs, as we've probably discussed previously, have their own separate storage capacity, and it is a tremendous amount. Just to give you a little better sense of them, this is a saline formations assessment, and it focuses the fact that the high estimates here in million metric tons are enormous, just separate different basins. We're talking about basically 1 million metric tons. These are million metric tons, a million metric tons. So again, these are theoretical capacities. They're not functional capacities, but nonetheless, saline aquifers offer an enormous resource for capturing and storing of CO2 offshore. Now, in that respect, still sort of zooming in, a lot of the projects we're talking about are all lined up along the Texas Gulf Coast, with an emphasis on Louisiana and Texas having the most capacity. As we know, Texas produces an enormous amount of CO2. It's the 6th global producer if you count it as a separate nation. It has basically more than the next 2 states, California and Louisiana, combined. So as a result, there's a lot of opportunity if you view CO2 emissions as a reservoir resource to consolidate and transport offshore. Right now, annually in 2018, that's 390 megatons of CO2 in the Texas areas. Now, statewide, most of these emissions are from power plants, and that's relevant legally, as Romany highlighted briefly a moment ago, and I'll get into a little more detail in a second. But if you get down towards the Gulf Coast, if you look more into sort of Houston, Beaumont, Port Arthur, South Louisiana area, the CO2 profile changes. It's not coal-fired power plants, although we do have 1 or 2. It's really more focused on chemicals, refining, petroleum and natural gas handling. And as a result, we're talking about collecting CO2 from different types of sources that have a different legal status. Now, with this map, you'll also notice a few other things. First of all, notice there's a small kink And I'm not sure my cursor is showing up on your screen, but if you look at the line, state line between Louisiana and Texas, that there's a jump outward. Texas, as Romany's map pointed out earlier, actually has a broader territorial waters. It goes out to 9 nautical miles as opposed to the typical 3. That means that there's a substantially larger area that Texas has primary regulatory authority over versus the United States. And frankly, that's a matter of some interesting historical basis because it actually is rooted in the fact that Texas entered the United States as an independent nation rather than as a territory. And as part of its admission was exceeded these broader coastal areas. Notice as well that as part of that, we have large reservoirs in state waters, not necessarily federal. And that some of these reservoirs were actually shallow production formations that have been used previously to produce oil and gas and theoretically have some space available to them. You'll also notice here that there's existing pipeline infrastructure already in place for conveying CO2. And I couldn't resist noting as well, one of these pipelines closes near an area that's marked as a production source. That's the Petronova unit at the NRG Energy coal-fired power plant in the Friendswood area, which some of you may have already discussed previously, has been shut down because low oil prices have made enhanced oil recovery unprofitable for them. One other quick note I just can't resist throwing in, although it's not really related. We also have the Strategic Petroleum Reserve in this area between Houston and Beaumont, Port Arthur, which is currently salt domes, as we all know, underground, that store over 700 to 800 million barrels of oil for economic buffering purposes to protect against boycott shocks or other oil spikes. It's interesting to think that as we pivot from petroleum and as we increase domestic production sources, that the need for this buffer is no longer quite so clear, that there's talk about repurposing the Strategic Petroleum Reserve and selling off more of that petroleum and perhaps freeing capacity. And I'll also note in passing that salt domes are an excellent geologic formation for storing CO2. Now, moving in, we've talked about some of the physical issues of this that has legal consequences. And I'm not going to repeat what Romany said, but I will sort of touch on it briefly to remind everybody that if you want to go into federal waters, and those are those waters out further away from the coast, past 9 nautical miles for Texas, 3 nautical miles for Louisiana and for other states, you have to go to BOEM, the Bureau of Ocean Energy Management, to get the lease. And under federal law, they can't give you a lease for storing CO2 unless that CO2 is coming from a coal-fired power plant. And as I mentioned previously, that ain't the case for Texas. It's not the case certainly for the coastal areas of Texas, where most of our CO2 comes from a mix of different sources. So essentially, federal waters are problematic for us. At the same time as well, Romany pointed out that the Marine Protection Research and Sanctuaries Act, as well as the Ocean Dumping Act, also prohibit the disposal of CO2 as an industrial waste from a manufacturing processing plant into federal waters. So as a result, we might be able to navigate, and certainly to the extent that pending infrastructure legislation solves the problem, we might be able to work our way through some of this. But the bottom line is that federal waters are going to be more difficult for a pure carbon capture sequestration play associated with ocean CDR. I will note there might be a wrinkle, and I'm throwing this out without any basis, or just sort of provoke a conversation. These strictures on the legality of ocean-based CCS in federal waters may have a different framing if that CO2 is not being simply sequestered, but is instead being used as enhancement of production from a lease given to an operator for other reasons, for oil and gas production. Just as I'll talk about in a minute, federal land law for terrestrial onshore sources treats wells that inject CO2 for sequestration differently than wells that inject CO2 for enhanced oil production. There might be a similar dichotomy for offshore production facilities that use CO2, even if they were a pure sequestration play, that they may not have the same sort of clear space legally. It is, I will simply say, not something that is gets a lot of attention because, frankly, formations and deep sea production in particular, but for offshore sources, haven't needed that type of enhanced CO2 recovery that you'll see with terrestrial wells. But nonetheless, legally, it presents an interesting question that might get some more attention if the federal laws don't become more accommodating. Now, beyond, in that respect, I just want to point out again, this is the mix showing that along the Texas coastline, the coal-fired power plants that would be the normal source of the gas, the ones that are talked about in particular by the federal laws that limit it to just offshore sequestration for those sources. Notice the color of the dots down here. The bulk of them are chemical manufacturing, cement. You're looking at, interestingly enough, iron and steel in some locations, natural gas processing distribution, not coal-fired power plants. So with that in mind, that's federal. We talked about some of the pitfalls in the federal framework. What if you go inside the line within that 9 nautical mile limit? Well, the laws, as Romany pointed out, change. And instead, you are now dealing with the Underground Injection Control Program of the Safe Drinking Water Act. And it essentially has 2 boxes: Class 6 wells, which are pure play sequestration wells, and Class 2 wells, which use carbon dioxide to enhance oil and gas recovery. Class 6 wells offer some legal advantages, such as a conditional exemption for hazardous waste requirements that might apply to some CO2 streams. They offer some other potential exemptions from cleanup liability, but it's a pretty demanding program, including in terms of demonstrations for pure long-term stability of the sequestration. Class 2 wells, since they're really viewed as economically driven more than sequestration driven, that essentially to do it profitably, the assumption is that you're not going to waste your CO2 if it's being used to produce oil and gas. They are going to, the federal system doesn't impose the same sort of rigor for the operating requirements for Class 6 wells. So notice though, this Class 6, Class 2 well framing applies onshore and offshore for state water wells, not federal. So what does that mean for ocean CDR and for CCS as a sort of demonstration in Texas? It means that effectively we are going to be looking at offshore capacity largely being tapped in shallow waters that are going to try probably to take advantage of state laws and take advantage of either existing infrastructure that's in place for oil and gas production, or alternatively, it's going to focus on tapping saline aquifers or other types of readily available geologic resources for which we have pretty significant information. So to give you a sense right now, the Bureau of Economic Geology at the University of Texas has estimated that there is a capacity of about 559 billion metric tons just in the Western Gulf of Mexico to sequester CO2. There's another close to 5 billion tons available for enhanced well recovery storage operations. So that which box you're using does change the different types of capacity that might be available to you. But also notice the way this is structured, the line that's the existing pipeline that's sort of in between, this map, I should point out, it is hypothetical. It is offering a concept of where CO2 capture hubs might be placed and where pipelines might be built to store CO2 off-site, off into the coast. Notice, however, that one of the formations that is in the middle of this is the High Island Formation, which is sort of right between Port Arthur and Houston, right in the middle of the picture along that green line. And it's a nice indication of where you might see some developing conflicts. We think about offshore storage as fairly uncontroversial for some of the reasons that cause problems for onshore, because they're away from people. You have low risk of contaminating drinking water supplies, but you can still have competing uses of land. And in particular, High Island is a world-class rookery. It actually is an area where you will see people literally traveling in from Japan, Germany, around the world to see an area where birds, as they migrate up the Gulf of Mexico, actually build a concentration of nests that's really unparalleled. Amazing to see. And High Island is exactly the formation that they're talking about repurposing for CO2 storage. So we could be seeing some interesting possible nature versus sequestration debates, which, you know, it points out that this is not a simple win-loss proposition. You may be talking about competing benefits. So again, sort of getting in a little bit more into nitty-gritty, there's clearly a public policy imperative to try and make this work at the state level. They want to tap this resource in state waters, tap this resource on state land. But we've had difficulties because the agencies who permit these Class 6 sequestration wells, well, we had two competing for authority. One is our Railroad Commission, which is kind of an odd name, but it's essentially our Energy Commission, and the Texas Commission on Environmental Quality, our EPA. As a result of this friction that was slowing down consideration of wells, they've consolidated all of the permit authority in the Railroad Commission. And a letter, all the TCQ can provide is a letter of determination that they think the well is protected environmentally. This new legislation, which was just passed this summer, expressly applies to offshore CCUS. And it explicitly directs the Railroad Commission to seek delegation from EPA to run the program in lieu of the federal government, and that to seek delegation authority to run Class 6 wells. Interesting enough, it also bars the reopening of closed wells that were previously used for disposal. You can't go back and bring back zombie wells and repurpose them for CCUS under this new bill. Now, you combine this new legislation with legislation that was passed a few years ago that clarified that offshore CCUS was something that would be essentially unify the ownership of the pore space, which is usually a big issue with onshore because no one's really clarified who owns the holes in the ground as opposed to the oil. It also clarifies that once you put CO2 in the offshore formation, after that formation is closed, you're not putting CO2 in there anymore, the state takes liability. So as a result, you don't have the long-term liability concerns you would see with other types of onshore facilities. So they've basically tried to legally set the stage to make this more possible and make an effort to do it. So to wrap up quickly, it has already resulted in the first offshore lease request for proposals from our General Land Office. While the Railroad Commission permits the wells, the General Land Office actually controls the land that the state owns. So they get to auction the land and the Railroad Commission permits the operation. The money doesn't go to the state, it goes to support schools. It's already pre-dedicated. So it's going to create some interesting dynamics because our school land board basically decides which projects to approve. And as a result, the first auction was held and Talos Energy has submitted the first successful bid, and they are going to be basically running it in a partnership off of Jefferson County, the Port Arthur area, to do an offshore sequestration facility. So what does this all mean? Let's tie it all back to what I promised to ocean CDR. I think I'll just offer some fairly broad strokes. First, location matters. How far out from the coast you go will make a big difference as to what laws apply and what sort of permits you have to get, and frankly, how readily you can get this in place and what infrastructure you can count on to get it done. Second, the source matters, where you get your CO2. As Romany pointed out, coal-fired power plants have an advantage now, but that may change with the new bills. Some CO2 that comes from air capture gets a different tax status as opposed to CO2 that's used for other purposes. So you need to figure out where your CO2 is coming from for ocean CDR. The use of it matters. If we're using the ocean captured carbon dioxide to manufacture air capture fuels, like the Navy had proposed at one point, for enhanced oil recovery, you'll have different standards and liability. And the impacts matter. You're going to have a different potential environmental footprint if you're doing ocean CDR. So as a result, you may have to worry about what type of protected species under the Marine Mammals Protection Act or the Maxim-Stevenson's Act, as opposed to dealing with the Dangerous Species Act or other sort of terrestrial-based ones. So with that, I think that this sort of gives you a sense that ocean CDR is going into an area that has already been, to a certain extent, explored by people who want to do offshore CCUS. And the two are probably going to have to go arm in arm to some extent, at least for the next couple of years. And the lessons learned by one will hopefully benefit the other. And with that, I'll turn the microphone back over to Sarah.
Thank you, Tracy. That was a really interesting dive into some specifics. So next, I will be going ahead and sharing my screen And hopefully, I always have trouble with this. I wish that PowerPoint and Zoom would be better with each other. All right, here we go. I want to share that, and then I'm going to present that. Yes, okay. You should be seeing my first slide. So throughout the conference, it looks like the wording has disappeared. That's basically my name. Sarah Cooley, Ocean Conservancy. I will be talking a little bit about the insights that we can get from the verifiability of carbon capture and sequestration and what that tells us about ocean CDR. So throughout the conference, we've already heard a lot about the site-specific and sector-specific policy considerations that are relevant to ocean CDR. But we're always kind of presupposing that ocean CDR is actually going to provide a cost-effective and durable way to capture and sequester atmospheric CO2. I want to zero in a little bit on this idea, and I want to use some insights from CCS and their ability to be verified to shine a light on the existing gaps that exist related to verifying other ocean CDR techniques. And my point of view is informed by my training as a carbon cycle scientist and my current work to apply the best available science into ocean and climate policy. So here I've put some thoughts together based on what's out there, plus a little bit of expert judgment and hand waving. So definitely open to discussion and challenge. Oops. Oh, hey, check it out. There was my, okay. Oh, that's fun. All right, what is MRV? So MRV is a concept that originated with the Bali Action Plan in 2007, which was adopted by the UN Framework Convention on Climate Change during the Conference of the Parties 13. So the Bali Action Plan document called for measurable, reportable, and verifiable greenhouse gas mitigation actions and commitments in both developed and developing countries. But it didn't define what MR and V are, what they apply to, who should undertake them, and how should they be undertaken. So subsequent work since then has better defined the idea. So the long story short here is that monitoring, reporting, and verification are central to implementing nationally determined contributions. And nationally determined contributions are the promises that nations make about what their emissions profiles will look like going into the future, so that we can all work together to meet the Paris Agreement. Let's see, entities have to measure their carbon dioxide emissions or their capture. They have to track the effectiveness of any capture or storage actions, and they have to evaluate the impact of any of these actions. They also have to monitor progress over time. So reporting and verification of those results actually ensures transparency, good governance, accountability, credibility, and confidence that these results are being used effectively and that the best decisions are being made. So since then, the MRV concept has been applied, or has been kind of developed to apply to mitigation actions, not just emissions, excuse me, as they were originally thought of. So in 2016, World Resources Institute did a really nice white paper that really breaks down how MRV can relate to either emissions, mitigation actions, or the support provided to get everything done. And this figure zeroes in on the mitigation actions component. So the M part is measure or monitor. And the idea here is that data and information pertaining to emissions or mitigation, estimating those emissions reductions using data about activities and the efficiencies of those activities. And then this is an important piece, calculating the changes that are relevant to sustainable development. And then finally collecting all that information to support the report step, which is the R. The reporting step is really compiling that information in inventories and standardized formats so that it can be accessible to a large range of users, and it can help facilitate public disclosure of the information and better decision making. And then finally, the V part is the verify. And as it relates to mitigation actions, we have to basically subject the reported information to some kind of review or analysis or independent assessment to determine how complete and reliable that information is. Verification really helps to ensure the accuracy of the information, as well as conforming to any procedures, like, for example, any plans for mitigation that are written into a party's nationally determined contribution. And the verification process is a key piece of providing meaningful feedback that helps improve the process. And as you recall, the whole idea behind the Paris Agreement is that nations will revisit their nationally determined contributions and make them more stringent over time. And so the MRV piece is a really important piece of making sure that what we're planning to do is actually panning out and doing what we think it will do, and then finding ways to improve upon it. So when we think about seabed carbon capture, I propose that it's uniquely ready for MRV, much more so than a lot of other methods. And the reason I say that is because when we're thinking about carbon capture, monitoring and verifying that is pretty easy. It's straightforward to know how much carbon dioxide is collected from an industrial process or from the air. Likewise, it's very straightforward to measure and verify the storage. Romany was saying that there was, I think I wrote it down, but it was an actual percent, they're looking at like 95% capture into basalt over 2 years. That is so specific and so clear. It's very straightforward to measure how much carbon dioxide is making it into mineral formations. Likewise, you can quantify escapes. And escapes would kind of appear to be point sources. So a network of detectors along your pipeline or along your transport and storage infrastructure would do the trick. These efforts are geographically fixed. They have to rely on geological structures that aren't moving anywhere. And so it's very spatially well defined, and that means it's also very restricted to a particular jurisdiction. So hearkening back to what the previous speakers mentioned about whether something occurs in state area or federal area, very important because the regulatory processes are very different. This method also has a really well-defined durability and stability. So when the minerals that capture the CO2 are finally created, they're very long lasting and very stable. And that's something that can be determined in the laboratory, confirmed in real life. It can be modeled with a high degree of certainty. There's also no biogeochemical risk. This process is not going to alter land or ocean biogeochemistry. It's not going to cause ocean acidification or deoxygenation or anything that would kind of alter the overall ocean environment. So consequently, there's also very low ecological risks. Apart from microbes in the geological formations that might be disturbed, or marine life that might be disturbed upon building of any infrastructure, there aren't substantial ecosystems that would be disturbed over time. And so all in all, there's very low public risks, policy risks, diplomacy risks. People are already pretty okay with this. Transboundary risks are basically non-existent because the carbon dioxide is going into a geological structure under a jurisdiction's control. There's a really low possibility of harmful human impacts. You're not going to be seeing a nation kind of suddenly saying, oh, by the way, your carbon plume came into my space, because all that is kind of disclosed or evaluated at the start when the geological structure is chosen. So comparing carbon capture and sequestration to other ocean CDR options using this sort of MRV framework was very, very interesting. So I used Seabed CCS as our sort of unicorn example. It's over here highlighted in yellow. I looked at those same 7 parameters that I just talked through for other processes. So I looked at whether carbon capture monitoring and verification was easy, carbon storage verification and monitoring were easy, is escape quantifiable, is the process geographically fixed, does it have a defined durability and stability, and then the sustainable development goals kind of considerations. I'll talk about that in just a second, but the 3 dimensions that I thought about were very broad sort of things that are connected to the sustainable development goals, but not maybe explicitly a sustainable development goal. So those 3 dimensions were whether there's a risk of ocean biogeochemical change, acidification, oxygen loss, eutrophication, whether or not there's a risk of ecological or human impacts from either direct impacts to animals or indirect impacts to animals, ecosystems, or perhaps the services that ecosystems provide for people. And then the 3rd dimension was kind of that political risk. Is there a risk to the global commons, to peace and security, public opinion? So Seabed CCS, you've got sort of yeses all the way in terms of what it does to help you with greenhouse gases, and you've got no's all the way through on sustainable development goals. And just as a quick reminder, I'm just going to flash forward to talk about the sustainable development goals for a quick second, and then we can go back and take a peek at this slide again. So the sustainable development goals are a set of 17 principles that nations have adopted through the United Nations. And the idea is that these goals will be met ideally by 2030. And so the risk of human and ecological impacts, I roughly, estimate that these risks of ecological and human impacts to anything in the ocean would put in jeopardy the sustainable development goals relating to poverty, hunger, decent work, reduced inequalities, responsible consumption and production, risks to ocean biogeochemistry, pretty much endanger things related to life below water, Sustainable Development Goal 14. And then the final group of risks to global commons really go to the heart of the governance Sustainable Development Goals. So peace, justice, and strong institutions, and partnerships to help achieve the goals. So that's kind of how I was thinking about how those 3 risk factors that I talked about would actually relate to sustainable development. So going back through some of the commonly discussed ocean CDR options, I really was intrigued to find that there are pretty much anytime you're adding anything to any carbon to the water column, or adding any iron or alkalinity or nitrogen and phosphorus or crop waste or macroalgae, you can very easily monitor and verify that you are putting in a certain amount of material. Now, the stars I've added really point to the fact that there's a conversion factor necessary to connect the input of iron or nitrogen and phosphorus or alkalinity with a carbon dioxide, currency that we're interested in. And then likewise, in all of those cases, it's very hard to monitor and verify that you have stored the carbon dioxide, because you are relying on a number of biological or geochemical processes to actually do that work for you. And so that's why all of those approaches get, sort of, no, they are not easy to monitor the storage, or like at this time, they're really not easy because you've got to rely heavily on models. Likewise, we have for the up and down welling, that's a little bit different because it's really not easy to, this is artificial upwelling and downwelling. It's really not that easy to monitor and verify carbon capture from those. And it's not that easy to verify that it's stored. It's not that easy to quantify escapes. It's also not that easy to define the durability and stability. Likewise, with a lot of these other options related to that rely on sort of geochemical or biological processes. The problem
Sarah,
with things, yes?
Sarah, I'm sorry to interrupt. We can only see about half of your table. So I'm just wondering if you can zoom out maybe.
That is
It's such a good
strange.
table that I don't, that's
Let
it.
me see.
That was
You know
it.
what I'm going to do? I don't know what's going on here. I'm just going to do this mode. I know it's clumsy, but I'll just make it as big as I can here. Is that
That's
pretty
great.
visible?
Yeah.
Okay. I'm not sure what's going on. I'll have to have words with Microsoft. Okay. Let me know if that's not visible for some reason in the future. Thanks. Right. So the anything where you're adding material to the water column and kind of hoping that biogeochemistry is going to help you out, you also run the risk of ocean physics getting in the way and like taking that plume into another jurisdiction. And so in those cases, things that are not geographically fixed also wind up having a higher risk of transboundary conflict and other sorts of risks to the global commons and sort of peace and security. Finally, I thought it was very interesting to think about blue carbon protection and restoration as well, where there is when we think about the Sustainable Development Goal considerations, very low risk. It's also geographically fixed. Researchers are working on verifying the durability and stability of carbon storage in terrestrial and coastal and vegetated systems. But it's still pretty challenging to actually verify the carbon capture and storage that you are getting. So I feel like this was a very interesting exercise to go through because it really helped me think about why seabed CCS is a little bit of an anomaly in terms of how easily we can kind of say, yes, it is actually capturing carbon for us. Yes, it is actually a low risk option. And interestingly, a lot of those same characteristics are not there right now for many of the other proposed ocean CDR options. So when it comes to the reporting and verification potential, I guess, of other ocean CDR options, it really shows that we need a more nuanced approach to improve risk evaluation and verification of the carbon storage feature of each of these options so that they can be included legitimately in a national plan to mitigate carbon dioxide. So thank you. I will stop with that. And let's go to the discussion. Let me stop my share. Any clarifying questions? I know I kind of like threw a bunch at you. So I just finished a run on an IPCC chapter. So you can tell I even use some of the same colors. Can't stop. Any clarification questions that I can answer?
I actually have a question, Sarah.
Sure.
You talked a little bit about sort of the role of monitoring, verification, and reporting in the context of the NDC, and it sounds like that's sort of what you had in mind when you were formulating your topic, but there are also sort of MRV issues around sort of if we want to use these techniques to generate carbon credits or offsets. Do you think that changes anything in your analysis if you look at it from the offset credit side?
I don't know. I'd want to think a little bit more about that question and kind of really think in a little bit of detail about each of these options. I think that if there is a carbon market in place, it changes the risk profiles pretty substantially for some of these things. And I think it changes people's tolerance of the risk. And it also permits some of this verification to happen in like a third-party way. One of the speakers yesterday mentioned how expensive it really is to verify things correctly. And so I think that would change if there was a carbon market situation. Other thoughts? Questions? Okay, let's move to the Q&A discussion part of the panel. I welcome anyone to raise their hand and pose a question to the panel. I have a few questions that I could definitely ask because it's really fun to have such a great group collected to chat through this. Let me see if I can look at, let's see if I can look for participants, because then I can see hands raised. Okay, either hands raised. And if you're having trouble with the hand raising, you can always use the chat, but it might be hard for us to trace that.
Antonius had a question in the chat actually for you, Sarah.
Let's see, what was Antonius's chat? What does this mean for verification? Could we factor in uncertainties? Well, I think that's an interesting question because one of the things that occurred to me is if you have leakage or an inefficient sequestration process, there needs to be almost like a rheostat to your related to your storage. And I think that would need to be confirmed over, and rechecked over time. I think there's probably a way to factor in uncertainties, but as far as I know, the system is not really expecting that at this time. But perhaps that needs to change.
Yeah, I'd just say it's definitely something that comes up in the sort of when you're thinking about policies to incentivize carbon removal, the longevity of the storage, how that's sort of priced in if you're providing something like a tax credit for that. I think, raises some really interesting questions that I'm not aware of anyone having a really great answer for, but certainly something that needs to happen when you're thinking about whether it's a 20-year storage or a 100-year storage or a sort of more permanent storage.
Well, that actually brings up a question, Romany, that I've been thinking about for a while, and maybe we should kind of, use this to kind of kick off our discussion. I think the question about uncertainty or inefficiency of storage is also related to this idea of timescale of storage. Each method is going to have a different permanence, durability of the storage. Is there a role for things that, for methods that sequester carbon on the order of decades? And how do we actually incorporate that into a legal framework or a permitting framework? Because I think you can come up with any kind of equation you want in the verification and sort of reporting framework, but I think practically speaking, how does that happen? Tracy, you mentioned something about the lock-in effect of infrastructure. And I wonder if either of you have thoughts about this like timescale question.
Probably I'll jump in if you want, unless you have something you want to immediately offer up. I'll simply say, in terms of what the regulators are saying, right now the expectation is they're expecting about 1,000 years service on the sequestration wells that they're looking for offshore. So there's an assumption that the monitoring technologies are going to catch up to the regulatory demand. Having said that, in terms of what a role might be for short-term carbon removal, absolutely. I think we're in a position where anything is desirable. The question is whether we need to include essentially a discount rate. To a certain extent, the weighting of the carbon is going to have a time value associated with it. So that essentially a ton removed for 10 years is going to have a tenth the value of a ton that's removed permanently or fixed geologically.
Like a reverse discount.
Yeah, I don't want to discourage people from putting out the fire in front of us, but at the same time, we have to be realistic. Just cycling it's not going to be terribly helpful, as opposed to something like CarbFix or some of the technologies Romany is describing, which will permanently fix it, geologically fix it at a scale where it's effectively permanent.
Yeah, I mean, it certainly seems like there's value in buying time to the extent that we can buy ourselves time using some of these techniques that involve sort of shorter term storage. But as Tracy says, that needs to be factored into the legal and policy framework so that we make sure that we're not sort of overcounting removals here, both in terms of sort of the NDC side and also in terms of the how we're paying for this side. You know, where there's debates happening in New York at the moment around having sort of effectively like a government procurement of carbon removal, where the government would pay for carbon removal. And the current draft of the state bill that would do that assumes removal for 100 years. Well, how do you treat projects that initially think that they will remove carbon dioxide for 100 years but don't? And so, you know, can you get some of the money that the government has paid back? How do you treat projects that know upfront they'll only store for 10 years, but still have some value in that short-term storage? So it's definitely a situation where the law and the policy needs to match sort of the reality on the ground.
Yeah, and I'll just throw out an idea that just bubbled up from the subconscious, which is I think everybody on this call is particularly sensitized to the concept of peak shaving. You know, to a certain extent, do we need an accounting for the peak shaving period when we just have to sort of bend the curve and then transition to a more stable reduction framework once we get past the moment of need? Certainly that's been the framing for a lot of the climate intervention discussions, but I haven't really seen it applied to carbon valuation and what sort of ton of CO2 is worth, both for financial, but also just frankly, calculation purposes.
Thanks. I see a hand. I see Andrew. Would you like to come off mute and ask us your question?
Yeah. Hi, Sarah. How are you?
Hey, how's it going?
Yeah. Thanks for your talk, and I really was the table especially is really stimulating my thinking on this and clarifying some things that I've had, you know, like uncertainties that I've had in my mind in terms of how all these different approaches might show up on a risk matrix like this. And I think the points that you made about like all of the sort of greenhouse gas considerations, especially are really relevant for this community, and looking at the the companies that are looking to turn this into like a quantifiable, and measurable and profitable operation. It really makes me think more about the CCS side of things and lean towards that in my thinking. What I was wondering is, are you, some of the other sections in there options focus on, things that have co-benefits for the ocean, and you're mostly considering like the risks, and I wonder how can we figure those things into in terms of biological production, fisheries benefits, or ocean acidification mitigation, and how does that factor into it, and what sort of value could be attached to that?
That's I don't even want to say $64,000 question, because it's bigger money than that, I think. I think trying to figure out how to sort of co-value something as concrete as carbon removal with things that are as complex as biodiversity and well-being of human communities has bedeviled folks for a long time now. I don't think there's any straightforward answers. I would be curious to hear from Tracy and Romany whether there's sort of like, policies. I think that the point that Romany made about how, there's these sort of like policies that are officially in conflict with each other, but they're being brought into greater alignment. I'm curious to hear a little bit about what potential we have to fold in added benefits or added incentives to feed people or employ people. I mean, I thought about the employment bit a little bit as I was putting together this table, because I was like, let me just assume that all of these activities are equal in terms of job creation, which is probably not true, but they're all good for that to some degree. But when it comes to providing additional food sources or supporting aquaculture or whatever, I think that's untapped. So I'm curious about what the other panelists will say about the ability to incentivize via, as we also bring policies into alignment with each other.
Tracy, you want to take this really simple, straightforward question first? I would say that I think that the question of co-benefits and how to account for co-benefits is really a challenge. I would also say that I think the question about how to approach risks is really a challenge because, none of these approaches are risk-free. Even the CCS approaches that are, the storage is, as Sarah said, somewhat more measurable and verifiable. There's still risks along the way, a pipeline rupture, all sorts of things. So we can't eliminate all risk from these activities. And I think there's some really difficult sort of societal questions around what level of risk we think is appropriate here, given the risks we're already facing from climate change. And then on top of that, we have this question about sort of co-benefits. I do think there are opportunities to, we could potentially, and I haven't sort of thought about this in great depth, but I think there's sort of learnings we could take from some of the discussions around ecosystem services and how we value those ecosystem services and lay it on here. But I think there's a challenge in potential sort of double counting that we need to be very mindful of, because we do have limited resources to address the climate challenge and many other sort of environmental and overlapping challenges. So I think, there's not an answer, but it's at least it's sort of my initial reactions to how we sort of at least should start approaching these questions.
Mm-hmm. Tracy, did you want to add some thoughts?
Honestly, Romany captured, I think, most of what I would have thought, other than I will do the politician's trick of answering the question that wasn't asked, which is, to a certain extent, when you say co-benefits, the other thing I'm very interested in seeing, and I will gently note that I'll be hovering over my computer for the NAS Ocean CDR report when it comes out, but it's under strict lock and key. But I'm expecting to see some discussion of co-benefits in the context of activities that are not designed to remove CDR, but can have that collateral benefit, which is sort of the doppelganger of the co-benefit discussion of calculating environmental benefits from CDR. I mean, to a certain extent, it's going to change the economics for things like desalination or blue carbon or other types of economic activity that, previously we've kind of used the enhanced oil recovery model for. But when you start factoring in some collateral benefit of capturing and sequestering CO2, particularly if 45Q gets ramped up more, we're going to start seeing a lot of things that were on the margin suddenly become profit makers, and we're going to have to start rethinking what it means to capture CO2, frankly.
Yeah, those situations where CO2 capture is the co-benefit and you're primarily doing something for a variety of other purposes.
Yeah, honestly, I think that's where a lot of the action is going to be.
Well, I think our society is complex enough that we are going to have to grapple with this sort of multiple benefits problem in a lot of different formats. So, I expect the public conversation on this will advance. Will, I see you have a question. Come on, jump in and ask us, please.
Yeah, so I think it was maybe a year ago, I remember Senator Menendez released this report indicating that the vast majority of 45Q credits were claimed by companies that weren't really complying with much of anything in terms of reporting. And I was wondering if any of you had an update on that or any thoughts about how we can ensure the integrity of 45Q, because quite frankly, if that becomes the experience, I think it's going to really undercut a lot of the incentive mechanisms or appetite for incentive mechanisms, both here and abroad.
Yeah, I think there's been some real challenges in the past experience. I would say that the IRS has just come out with a whole new set of regs, including some like in the last couple of months. So it will be interesting to see. I have not dug into the minute details of those regs, but it'll be interesting to see whether and how that changes things. It certainly does seem like there was somewhat of an oversight gap in the past enforcement. You know, I also think the last panel had a very interesting discussion of sort of intergovernmental cooperation around these issues. It seems like this is a prime area where we need more of that intergovernmental cooperation because the IRS is not a particularly well-equipped body to be assessing sort of long-term carbon storage. So I think there's a real need for enhanced coordination and cooperation across agencies in that context in particular.
I'll just throw in a quick me too. There was a lot of comments on the 45Q guidance and regulations, specifically on MRV and permanence of the sequestration. I think Senator Menendez's comments got a lot of attention. And as a result, the rules do make an effort to try and pin that down. But I will also say whether the IRS is the right agency or whether or not they want to do it. I think the fact that we are focused so much on border tax adjustments is a core part of climate policy right now. I think they're stuck with it, and they're going to be probably the gatekeeper for some of the validity of CO2 removal activities if there's going to be a financial tax benefit associated with it.
Thank you.
Will, did that answer your question, or did it spawn another one?
Nope,
Okay.
that was great.
All right.
Thanks.
Old hand. Okay, thanks.
Well, but Sarah, I will say as a small note, unless Will's planning to mention this at the end of the conference, I'll put in a small plug that he got to ask us a question, so I will return the favor when he speaks at the University of Houston next week on ocean CDR. So hopefully folks will be able to tune in for that one too.
And maybe I can give a small plug for a program that the American Bar Association is running on Friday about carbon border adjustments, since Tracy just brought that up. Sorry, Will, we're co-opting your.
No, it's great.
No, this is great. This is like helpful, you know, additional things. Andrew, I see you've got a hand up again.
Yeah, one more question. There was mention of the saline aquifer reservoirs and also like the basalt reservoirs and different reservoirs. And it seemed like one of you mentioned that there's plenty of capacity in even the saline reservoirs that are terrestrial. And I guess, is there a matrix or something that says like Sarah's figure or something that says like what those different reservoirs are more useful for, or what's easier to sequester CO2 in, and why we're even, you know, if there's plenty of capacity in the saline reservoirs, why are we even considering, you know, like going offshore where it's going to be more expensive and stuff like that?
Why don't I throw myself on that one first, and then Romany, you can clean up the mess afterwards. Short answer is the numbers I see for saline aquifers are really kind of astonishing, but for that same reason, I'm also a little skeptical. I mean, when you see reservoirs in the United States that are clocking over 1 trillion, that strikes me as a theoretical calculation, not a practical one. The other thing about saline capture of CO2 is it's like coal bed methane. I understand is that it's essentially remains in a gaseous state, and that it doesn't offer the same advantages of a geologic sequestration of basaltic formation, where it actually gets rendered geologically into an inert form. So the reason people talk about it is that the aquifers that were, you know, that get the attention, particularly in the National Petroleum Council reports, those are well known from oil and gas operations. So we actually have well cores and seismic records that really give a pretty good sense of what's there. But you know, that data was collected for other reasons a long time ago in some cases. It's kind of fascinating reading the Bureau of Economic Geology's report. Now they're going back and pulling out well casings going back decades and seeing what the core samples are, and they've actually kind of dried out and broken down. They really can't get data from them anymore. So I think there's a lot of hope about saline aquifers. The theory is very kind of impressive, but you know, in the end of the day, I'm not sure it offers the same sort of confidence, stability, and you know, frankly, verifiability, and that you're going to get from the type of formations that Romany's been looking at in the Pacific Northwest.
Yeah, I think there appears to be sort of advantages to the basalt storage. Still a lot of work to do, and you know, our projects are still in the relatively early stages. I would just say you asked Andrew about sort of why move offshore, given that it is more expensive, it's a hostile environment, the sort of wear and tear on equipment is really much greater, all those sorts of challenges. But there's also potential advantages. We have seen in the past a lot of sort of community opposition to local CCS projects, which may or may not be present offshore. There are sort of potentially fewer sort of use conflict issues with operating offshore. So there's sort of benefits and drawbacks to the offshore versus onshore environment that need to be sort of factored into the equation.
Yeah, and if I could add a little bit to that. First, one of those big benefits is the fact that you don't have to mess with owners. It's just one owner. So you don't have to worry about who has the pore space, forcing people to unitize, making sure you've got some multilateral contract that covers hundreds of parties. You just have to strike a deal with the state, be it federal or state level. So that helps tremendously. And that's why a lot of people are interested in offshore, even if an onshore well nearby offers the same benefit because it taps the same geologic formation. It's just legally, it's easier. But I'll also say one of the things I didn't add because I was worried it was a little bit provocative. If you take a look at a map of the Gulf of Mexico that shows pipelines, it looks like alligator skin. It's just cross-hatched all over. There's an enormous built-in historical architecture of pipelines for oil and gas development, but not all are in use. A lot of them are abandoned. A lot of them are old. So the benefit is you've got that existing infrastructure that makes it easier. It gives an advantage like Romany was talking about. The downside is that there's a legacy issue you have to wrestle with. There's an ongoing oil spill right now in the Gulf of Mexico from a ruptured pipeline. They're just trying to find out who's actually responsible for it because a lot have been abandoned a long time ago. So, you give and you take at the same time. I still think at the end of the day, folks are interested in CCS offshore, mainly because it's easier in some ways, even though technically it's more challenging.
Mm-hmm. Mm-hmm. Looking at the time, I notice we have a few minutes left. Would each of you like to offer some parting thoughts?
Tracy, you should go first.
After you, Alphonse. All right. I think what I'll just simply say is that there's a lot of interest in thinking of CO2 as a large-scale infrastructure asset that has to be managed down here. Frankly, as a matter of industrial survival for the energy sector. I have not seen the same degree of focus and interest on the actual capture and sequestration of CO2 outside of point source capture. So in Texas, we actually do have, and I keep talking about Texas, but we're sort of the ground zero, the crucible for trying to sort out some of this stuff in the energy transition. We do have direct air capture plants, at least the first scale model set up in West Texas between Oxy Low Fuel Ventures and Carbon Engineering. I think folks are starting to pay attention as to where they're getting the CO2 from. But frankly, folks here have kind of gotten used to thinking about CO2 as something they get out of a natural geologic formation or some other source that they have to buy so they can use it for enhanced oil recovery. It's a slower transition. It's going to take folks some time to realize that direct air capture and ocean CDR has got to be a vital part of that mix. And it's just going to, I think we're going to end up with the tail following a little bit slower here, but it will have to happen.
Thanks. Romany?
Yeah, I think, Tracy, it's such a remarkable sort of point that I think a lot of people don't realize that oil and gas companies actually buy carbon dioxide, extract it or buy it, pay money to acquire that when it's really this sort of waste product that we have way too much of and we're kind of trying to figure out what to do with. It's just, I think that's just a mind-blowing sort of fact in the world and really demonstrates the sort of fundamental shift in thinking we need, which is the point Tracy was making. I would just say that, when you look at the sort of legal and policy landscape, it does look like CCS is much further ahead, and for the reasons that Sarah mentioned, maybe there are sort of benefits to that approach versus some of the approaches that are I guess, less well developed. But I think the full suite of this conference has really highlighted that we need to be looking at every tool in the toolbox, and we need to, going back to our earlier discussion about sort of timescales, we need to be sort of thinking about sequencing in a way that I think hasn't really entered the conversation yet. Thinking about what we can do in the short term while we develop approaches for the long term is really important. And I think approaching the suite of sort of offshore carbon removal approaches, which includes CCS, but also includes these other CDR approaches, approaching that as a suite and building in that sequencing piece is going to be really important for advancing sort of the field and also advancing the law and policy in this space.
Thanks. I think for my last thought, it does build on what you mentioned, Romany. I think in addition to that sequencing and every tool in the toolbox approach, we have to be really thoughtful about that portfolio that we have, and recognizing that not all solutions are created equal. And, I'm especially keen on making sure that, we don't have false hopes about different solutions, and we're very clear-eyed about what they can do, and that the policy is built to accommodate the advantages and weaknesses of each option, and the co-benefits. So I think there's a ton left to do here on, learning about these methods and, every little detail about how they work and how do we implement them in ways that are compatible with the existing policy, infrastructure that already exists. So I think it's going to be a very exciting field to follow, and I'm excited to be following it. I'm going to pass it back over to Will. Thank you very much, Will, for the organizing the conference, and thank you to my panelists. This was a really fun conversation to have. And thanks to the audience for some great questions. Will?
Great. Thank you so much, Sarah. Thank you, Sarah, Tracy, and Romany. It was a great final panel. And again, a lot of lessons as we move forward. So we are at the end of the conference. From a purely selfish perspective, I've learned a tremendous amount the last couple of days. You always do with this group. And so I thank all of our panelists over the course of the 2 days, as well as all of our audience members who proffered excellent questions and engaged in the issues that we've looked at. I think it's clear that concomitantly with technological development, the need for building the regulatory and legislative scaffolding, the public engagement scaffolding, incorporating notions of justice and equity as we move forward to avoid the bad lessons that occurred as we developed our fossil fuel-based economy are critical. And I think there were a lot of lessons here that we can use moving forward. And so I look forward to next year's conference and continued discussion of these topics. I encourage you, once we've posted the recordings from this conference, for you to share it with others that may not have been able to join us. Obviously, these kind of things are most beneficial the more that we can diffuse it into the discussion. So again, thank you, everyone. I hope to see all of you for next year's conference, as well as at various other meetings during the next year. Goodbye now.